Hello, everyone. Great to have you back. We are now approaching the closing track of our competition. Our startups are getting ready to present their ideas, and we are all keeping our fingers crossed for them. Especially me, I keep my fingers crossed for all of you. And I do not envy the members of the jury because it must be very difficult to choose only one that will deserve to be the most creative, the special one of the whole competition. My name is Katarzyna Krupa, and I'm very pleased to be the host of this show, because for me it's a huge show to listen all those creative ideas. Ladies and gentlemen, I hope you're ready for the final track. Get ready also to hear from the most ambitious companies that they're putting the past pathway to reach a gigaton impact on the contribute to the global effort to decarbonize the planet. So if I mean decarbonize the planet, you all now know what is the subject of the final track. Ladies and gentlemen, get ready for Decarbonization of X. This is a very complex and diverse group, I must admit, from transformers producer through the data and AI solutions and EV chargers, electric motors. So a very diverse group is now ahead of their presentations. But before that, please let me introduce the members of the jury that will vote to choose the best participant. Please welcome Sherif Al-Said Ali, co-founder and CEO at CarbonRe, David Garufi, head of law, CO2 built environment at CRH, Andreas Schwarzenbrunner, partner and Speed Invest, Lisa Liu, investment manager and UVC partners, Danish Ganisan, investor at Queenor Ventures, Kai Martin, corporate development lead of Baker Hughes, Miguel Brandao, product manager, VPP at CleanWatts, Luisa Maitos, co-founder and chief innovation and product officer at CleanWatts, Derek Higashihara, principal at Acario, Christine Marie Kvalo Johansson, acting managing director at Queenor Ventures, Andrea Canepa, co-founder and CTO at Net Zero Insight, Louis Bransington, technology origination led at the BP Technology Ventures, Sean Dana, CEO at Ignite the Spark, Atip Trantivoravong, Chief Executive Officer at InnoPower, Oyet Elstein, SVP Global Strategy at EMEA Operations at Lakeside Software, Maja Krystowska, Development Consultant and Endava, Toby Chen, co-founder and partner at Odyssey Ventures, Ashel Lipman, venture partner at Extensia, Wolfgang Kehler, senior director strategic accounts at Corinex, Stefan Nagel, senior business developer, ventures and open innovation at Orster Venture and Open Innovation, Markus Laubscher, director circular economy and regeneration at Orbia. Ladies and gentlemen, our jury. Please give them a warm welcome. Before we start with the session, I would like to remind you the rules. Each participant will have exactly 3 minutes for the presentation. After the time will finished, then the jury will have 2 minutes to ask questions, and we will start counting the time after the first question will be asked. And I kindly ask the members of jury to ask the questions very briefly, as we do not stop the clock while you ask the question. Okay, as I mentioned, I keep my fingers crossed for all of you, so let's start with the first presenter. Vice President of Commercial Real Estate Business Development in Armco. Please give a warm welcome to Parag Rastogi. Hi, good luck.
Okay, so my name is Parag Rastogi. I'm VP of Business Development at Arbanco, formerly a research scientist with the company, now working on business development. So we are a company that believes in the decarbonization of buildings at scale. If we look at the IEA's reports from 2021, we need to reduce CO2 emissions in operational CO2 emissions in the building sector by 60%, while increasing the built area by about 20%. And to do this, we have to reduce energy intensity. So energy efficiency plays a key role, and we have to reduce on-site combustion. How do we do this? Well, we've developed a web suite of analytical tools based on building physics and machine learning to identify and quantify energy efficiency measures, electrification measures, and renewables on site, so distributed energy resources. This happens by ingesting utility and building data, of which we spent a lot of time developing lots of machine learning to clean and normalize. We take external and contextual data, because without contextual data, this other data means nothing. We pass it through a series of machine learning and building physics models, as I mentioned, and as well as some machine-augmented tools that must be run by a human being who has knowledge of the building. So we benchmark and sort the buildings that come through this process, allowing you to do a portfolio analysis, an analysis of the portfolio of buildings. Lets you do deep dive analytics at prioritized buildings, for prioritized buildings, generating energy conservation measures as well as renewables, and allowing you to finally track the carbon, the operational carbon, and manage it over a long time. We have gone through market. Our go-to-market strategy consists of direct sales. We have gone to utilities and ESCOs. So everybody in bold here is an existing customer at some level. We've gone through utilities and ESCOs that use us as a sales enablement platform for energy efficiency and renewables. We go through property managers and owners who have a long-term interest in the carbon performance of their buildings. We are looking at OEM partnerships with the likes of Schneider Electric, so they can use our engines in their platforms. And then a similar model with the system integrators and experts to use our engines to serve their customers. The opportunity is massive, right? I mean, it's buildings after all, right? I mean, who doesn't interact with a building? We spend 90% of our lives in buildings, right? But more importantly, we have already started generating revenue. We are targeting about 2 million by the end of this financial year. We use the American financial year. Our SaaS pipeline has grown 5 times over the last year to about 14 million. And what I'm most excited about is the long-term partnerships and resellers, of which I've been helping with, because that's what will get us really into the infrastructure side of things. The financial aspects, we are targeting about 10 million SaaS bookings by the end of 25 financial year, and I can go into that later in the questions. We're a diverse group, about 33% women, including the CEO and the head of product, and diverse backgrounds with lots of experience in this subject. Thank you very much.
Thank you, Parag. I'll keep that now. The jury has 2 minutes for questions. Are there any questions you would like to ask? Yes, there is one.
Hi there. Thank you for that. What's the typical energy savings potential you'd see using your product for a typical client?
Oh, it's very variable, but it can go anywhere from tweaking behavior to get the last 10 or 15% to all the way to going to like 60+% for older buildings, And then even taking buildings to net positive with renewables.
Hi, great presentation.
Thank you.
Esha Lipman from Extentia Capital. How do you capture the data from within the plant? I mean, do you add sensors? Do you use existing sensors? And how do you analyze it?
So we do use existing sensors when they exist. So the building automation system, we can capture data from that. We are not at the moment adding sensors because our customers aren't there yet. But you can imagine we built the infrastructure. Usually, the kind of data we need right now is for CapEx projects. So what I need to know is what kind of plant you have, not necessarily how it's functioning at the moment. That would be downstream from us, and that would be sort of the next stage. And the way we analyze it is you sort of standard time series analysis and sort of taking the building physics knowledge into this. So we know how it should behave, and then we benchmark it, and then we can tell you what's going wrong. Right?
Thank you.
Thank you.
No further questions from the jury? Okay, everything was clear. So thank you very much for your presentation.
Thank you.
Parag Rastogi, thank you. And thank you, jury, for the questions. And the second participant is Technical Account Manager from Blue Wave AI. Please welcome Robert Zafik. let me correct myself.
Yeah.
It's a Robert Refik.
That's right.
Yes,
Yep.
that's right.
Thank you.
Good luck.
All right, I'd like to start by thanking the Energy Tech Challengers for the opportunity to present Blue Wave AI here today, and the judges for your time and consideration. Blue Wave AI is a software as a service company founded in 2017 with the goal to increase the utilization of renewable energy by 10 to 20%. We've filed 17 patents with 3 granted, giving us a competitive advantage in fleet or optimization charging, renewable energy storage optimization, and enhanced smart grids. So the problem we're trying to solve is that most of the renewable energy that's generated today is lost. Renewable generation can be tough to predict, so operators tend to over-provision fossil fuel sources to prevent shortfalls. Our systems can better predict supply and demand to better utilize renewable energies. The electrical grid is getting more challenging to manage. So you've got utility scale renewable energy generation as well as local, and you've got residential EVs along with EV fleets being added on, increasing demand on already strained electrical grids. Blue Wave AI can come in and better predict the generation of renewable energy to either store or use it, while also controlling charging of consumer EVs and EV fleets to reduce demand on the grid, which will allow us to lower our need for natural gas and coal sources and increase our utilization of renewable energy generation. We see the total market, accessible market for this being worth $6.6 billion, representing a significant opportunity to decarbonize these various markets. So how does this all work? Blue Wave AI takes data from various edge sensors, grid asset data, market environment data, and fleet telematics. That data is processed by our Blue Wave AI system, and we provide dispatch and control signals for grid optimization or EV fleet optimization, while also providing increased visibility over these systems. One of the challenges faced by electrical grids is the rapid adoption of electrical vehicles, increasing peak demand, at that dinner time hour as EV owners get home. By controlling the charging, we can reduce demand on the grid, while also allowing EV owners to reduce their expense of charging by charging in off-peak periods. Managing electrical fleets is a bigger challenge than managing traditional fleets. As we transition to EV fleets, these managers now need to consider building loads, local generation and storage, how weather can impact range, as well as energy pricing. We can help with all of these challenges. We are making progress in distributing our systems internationally. We just announced our partnership with the province of Ontario for system-wide load generation and optimization. We have a partnership in Summerside, PEI, where we were able to host the first 100% solar-powered indoor rock concert featuring Bryan Adams, at least the only one we're aware of in North America. And we also have a partnership with Tata Power, where we made a 300% improvement over their predictive systems, saving them up to $6 million per year in operator penalties. We are truly creating an international customer ecosystem. Our diverse team consists of 40 employees with 7 new hires this year and offices across Canada. We recently completed our Series A financing for $9.5 million and are just starting to work on our Series B, where we're targeting $30 million to continuing developing our products and increasing our global penetration. Thank you, and I'll take any questions.
Thank you, Robert. Yes, now it's a time for questions.
Thanks for the presentation. Can you provide more color on your revenue model?
Yes, so depending on the partner that we're working with fleet companies, we charge on a per vehicle basis. So, if they've got 300 buses, we'll charge on a per unit basis. With our grid optimization, we are entering into contracts based on utility savings. In Summerside, PEI, we were saving them a couple $1 million a year, and we're getting a portion of those savings. With our EV Everywhere platform, that is a new launch for us. Initially, we're going to be offering it as a free app to gain traction and getting revenue off of ads, and then again approaching utilities about partnering on this to gain revenue through the decreased demand for utilities.
Is there any more questions you would like to ask? Yes, please.
Hey, thanks for the presentation. How do you differentiate from other players in this space?
A couple things. I think we're taking a more holistic approach than some are by looking at not only the renewable generation and the load demand, and balancing that with residential EVs, solar generation, and as well as EV fleet management. So I believe in some cases we're taking a more holistic approach than some that are just focusing individually on load prediction or individually on EV fleet management. So I would say a more holistic approach. We're also one of the only strictly Canadian companies, or at least companies in Canada working in this space.
We still have time for the last one. Okay, if there is no question. Thank you very much, Robert, for the presentation and answering the question of the jury. Yes,
thank you all.
Big applause for Robert. Now, please welcome the CCO of Boson Energy, Heikki Karl Zetterström. Good luck.
Hello, everyone. My name is Heikki Zetterström. I'm the CCO of Boson Energy. And you will never look at waste and think waste again when I'm done here. We started Boson Energy to take the non out of non-recyclable waste. Because conventional recycling tops out at 50 to 60% recycling rates, waste incineration is inefficient and dirty. Pyrolysis has a role to play, but depending on what you put into pyrolysis, you will get a toxic residue out, and that's not an end to waste to us. So the only way to really do this is gasification. And gasification is a hydrocarbon. So we get 8 tons of hydrogen out of 100 tons of waste in our standard unit. We also capture 100 tons of CO2. We produce a bit of heat and a glass slag, so no toxic residues whatsoever. But building a hydrogen business based on a hydrogen economy or infrastructure happening is like building a business depending on people traveling to Mars. So we're not going to wait around for that. So what we do is we deploy this hydrogen. Since we have it locally, we can deploy it as 160 megawatt hours of speed charging instead. And that is 40,000 liters of diesel replaced, 300 tons of CO2 avoided, and cheaper than diesel. Or we make 40 tons of green methanol on the spot, where it is needed, because waste is available where energy is needed. And this is very difficult to do with renewables, and will be for the foreseeable future. To make this fully vertical, we can feed the heat and the CO2 into a vertical farming facility, and in the end, we can make cell glass out of the slag, which is what I've sent around to the judges here. We have developed and own the core gasification technology, and it's been demonstrated at commercial scale up to TRL 7.8 with real waste. We have taken this from science to an integrated solutions together with some of the best partners in the world, and all downstream systems are established commercial technology, and that basically gives us unlimited capacity to scale from day one. Our founders and chairman have spent between 20 to 40 years in gasification, clean tech, and waste, including exits to Siemens, Nalco, and Veolia. Looking at projects, we've developed a solid project pipeline with the Swedish port. We're working with Swedish municipal incinerators, and we have are developing these projects together with equity and financing partners to basically produce this in a very profitable way. And we can increase by 20 times the profitability in the waste value chain.
Thank you. Thank you very much for the presentation. Yep, I'll take care of it. Now, judges, do you have any questions?
Thank you for the presentation. Have you identified any customers who are willing to purchase all the products, or is it different customers for the different products that you're producing there?
So in terms of for the incinerators, it is typically municipal corporations that are handling waste and also delivering fast charging to community fleets, to communities, etc. For the harbor here, they have a pressure to electrify and decarbonize their operation. So we will deliver hydrogen-powered port operation, electricity, and for fast charging, and then we're producing methanol with the rest, and then the greenhouses. Yeah. It is a distributed model, so.
Thank you as well for your presentation. Could you elaborate a little bit on the feedstock that's required for your system and any limitations it has and where you plan to source it from?
We have basically no limitation. Anything you can put into an incinerator, we can take. So there are limits in terms of calorific. We cannot go ultra low on calorific value, but anything basically non-recyclable that has been sorted, RDF, medical waste, hazardous waste, which is the advantage of the process, is that you can put stuff. You will not get anything toxic out, basically, regardless of what you put in. And I can add maybe the last slide there didn't show up. We're currently raising 10 million euros. We've raised 30 million euros to date. We're raising 10 millions now as a bridge to take us to contracting and bankable projects on a handful of projects in Sweden, Poland, Israel, and India.
Okay. Are there any more questions? No. I think it's clear. Thank you very much for the presentation. Thank you for being here with us. Our next participant is Head of Corporate Communications from Carbonauten. Please welcome Henry Beranek. Interesting website, yeah. The front page from the website.
Thank you very much. So most people believe that physical products, the production of physical products and CO2 emissions go hand in hand. And we are Carbonauten, a minus CO2 factory, and our goal is to, let's say, to change this. With our system, we take biomass waste, biomass residues, and turn them into permanently stable biochar. And then we take the biochar and process it to Carbonauten net materials, negative emission technology for various markets. So agriculture, polymers, the construction industry, all the way down to carbon removals. To be maximum efficient, we had to create our own carbonization technology that comes without any rotating parts, because this allows us to be efficient, because we can process materials even if they include nails, screws, stones, whatever, not a problem for our technology. If we set the parameters right, we are able to create a new super material called technical biocarbon. Carbon, anyway, is fascinating because carbon, there's no intelligent life without carbon. There are 20 million compounds in organic chemistry, but the technical part is important for us because we can adjust the polarity, the particle size, the surface area of our product. And this allows us, with this material, we are enabled to create, for the first time, a CO2 negative compound with which we can create CO2 negative plastic products. And there's a huge market waiting to be decarbonized here. So here are some proof of concepts. So you can see it works with different types of processing. I personally love the form case box because it's a tablet case for schools, and so we bring CO2 right into the classroom. Something that's funny when people ask, we have the best pipe product that you can wish for because it's renewable energy. So 5% of the energy that's generated during the carbonization is used for the process. The other 90% we can use for downstream processes like compounding or delivered to local companies. Here's our first factory in Eberswalde near Berlin. It's about to start now. And here are 42 Carbonauten waiting to scale up the whole system. And when we're talking about scaling up, this means we need more money. And that's why we are currently in a financing round where we ask for up to 27 million for the next -CO2 factories. We also included some charts for those that are interested in later. So if you want to have the pitch deck, then you can have it. And yeah, only one thing left to say. What's your plan for your grandchildren? Not for the investment, for your children. We have it. It's fuck CO2, and we would be delighted if you join us. Thank you very much.
Thank you. Now it's time for the jury.
Yeah.
And we have a first question.
Thank you. You're planning to build a very large plant and generate lots of material, and you showed a few examples of like pilot projects, but do you have anything in the pipeline which is actually going to go to serial production?
Yeah, those pilot products, also one of them, I also have a small box, a small version of it, that's going to be a production, a serial production, so it's the last step. It's not just a trial we made, so this is almost the finished product. When we go to the other markets, like the agriculture market, we also have a ready product that's already in field trials with local farmers in Germany and other places of the world. So we already have products, but we need to have more of those -CO2 factories running to generate the product. So, yeah.
How do you ensure that your biomass is sustainable?
Okay, of course, we never cut trees, never, ever. We only use waste streams, and those typically either rot, so then there's CO2 created, or get burned. And if we kind of prevent the biomass from those two scenarios, we create a sustainable biochar. And from then on, it's a good way. We never cut trees. This would be the wrong decision.
Will you maintain the build, own, operate model also in the future?
From our own factories? So
yes, are you continuing to?
So we will operate all of those factories because we have to, because it's quite difficult to make sure that the biochar quality, the technical biocarbons, have the right properties. So that's why we have to operate those factories, that's why we have to maintain them, and maybe this could lead to a franchise version of the rollout, but we also always have to be in operation. Yeah. So potential industrial partners that have a factory near their production site doesn't have to worry about the production of the biochar. That's what we take care of.
Henry, thank you very much. Thank you for the presentation. I really regret that we do not have more time to listen to the presentation and the contestants. Ladies and gentlemen, now we will listen to the presentation of VP Business Development from Green Air Fuel Technology. Please welcome Martin Spencer.
All right, thank you very much. Hello everyone, my name is Martin Spencer, and I'm excited to talk to you today about GAFT, a clean tech company situated in the Netherlands. At GAFT, we have developed an alternative route for the production of sustainable aviation fuel. As we all know, the aviation sector is a major contributor to greenhouse gas emissions and is a notoriously difficult sector to decarbonize. The most promising solution is the use of sustainable aviation fuels. However, there is a significant feedstock supply shortage. Waste oils and used cooking oil, for example, will not be able to meet the demand that will be necessary to satisfy new legislation such as the Refuel EU initiative. This is where GAFT comes in. At GAFT, we have developed a process in which biogenic carbon dioxide is utilized as a feedstock. This, in combination with renewable electricity and water, can be converted into an energy carrier through our patented electrolyzer technology. The energy carrier is then used in a fermentation reaction with our proprietary microorganism, which yields us high quality and clean feedstock that can be used in SAF production methods. The advantage of our feedstock is that it is abundant, meaning that we can alleviate the dependence on waste oils, and it is also of better quality, requiring no sort of pre-treatment process before being converted into SAF. We also have no use of fossil fuels or food crops, and overall have a better carbon dioxide footprint. Our method will outperform competition in the SAF industry by being more cost competitive. We have no energy-intensive downstream processing, and also require no separate hydrogen source as we produce our own within the process. There's also no costly collection of feedstock, and the process is extremely flexible, meaning that there are further opportunities for cost improvements. This is our team at GAFT, and together we have a wide variety of skills in the energy sector, both commercially and academically. We have a great understanding of the challenges of SAF and are highly motivated to take our product forward and to have a meaningful impact in the industry. Through the money we have raised so far, and with future investment, we will develop our pre-commercial pilot. We expect our first revenues in 2025, and from which we will develop our commercial pilot and obtain our first licensing revenues. So far, we have received a number of prizes, but most notably, we recently received an EIC Accelerator grant from the European Union, which will help us to achieve our goals in the upcoming years. Our vision at GAFT is that carbon dioxide is not a waste, but rather a valuable feedstock. And with that, I'd like to thank you for your attention, and I welcome any questions that you may have.
Thanks a lot. Two questions. So at what scale have you tested this, and where do you plan to source the biogenic CO2 from?
Yeah, so to answer your first question, currently, as I mentioned with these two steps, the technologies of those are separate in the sense that we have two technology providers for that, which are our parent companies. So the electrolyzer process we have our pilot for, and that's going to be tested at 0.1 tons of CO2 per hour in an industrial setting. The fermentation reaction, on the other hand, is slightly lower in the TRL scale. At the moment, we produce fairly small amounts of the fatty acids as a proof of concept. So in that sense, the two technologies are somewhat different in their development stage. And for your second question with regards to CO2, this is something that we're still sort of considering is what's best. Of course, the optimal solution would be direct carbon capture from the air, because this also makes sure that we have the best CO2 reduction overall in the process. And it is something that we still want to consider, and part of the reason that we're here is also to figure that out, where we want to source our CO2 from.
Have you considered kind of looking at heavy industries that are heavy CO2 emitters as well?
Yeah, so you mean from flue gas, for example? Or yeah, so our pilot that will be tested is actually going to use the CO2 from flue gas. Of course, the problem with using flue gas sort of at a commercial scale and also in the future is that in terms of what the actual overall CO2 emissions reduction is obviously not optimal because there's still CO2 emissions at the end. So in order to really have the absolute most CO2 reduction in our entire value chain, we would want to avoid the use of flue gas, which is something that in general carbon utilization technologies are trying to steer away from because we don't want to end up with these final CO2 emissions. And it's also important that throughout our life cycle assessment, we maintain the 65% that's necessary to count as a sustainable aviation fuel in the industry, which is EU regulation.
Thank you, Martin.
Okay,
thank you.
Thank you
We
very
are
much.
running out of time. It's an excellent presentation. Now it's a time for the next one. Please welcome from Greenwood Power, the CEO and founder of the company, Norbert Jusic.
The world is facing a major problem. Yeah? We are speaking about the energy transition from fossil resources to renewables, and we have many challenges to solve. And one of these challenges is to make the grid ready for the smart products. And we have here a big challenges like an inflexible grid. We have an old grid layout, and we have no smart devices in the grid, and we have utility companies have to invest a lot of money to get rid of this problem. The solution is to bring measurement points on every layer of the grid. That means bringing non-conventional instrument transformers, so-called sensors, which are transforming high voltages and high currents to lower voltages, then connected to IoT devices and transmitted to SCADA systems and cloud platforms. This is done with this kind of products, very small ones, small building, low energy resources are needed, approximately 80% less is needed compared to conventional products, and 75% less energy needed during the lifetime. As a Greenwood Power, we have developed already 20 different products, and we are constantly expanding our portfolio to become a full liner in sensors in the next couple of years. We have deployed around 250,000 products in the market so far. The market is rising very fast. It becomes approximately 2.2 billion euros up to 2031. Greenwood Power have a global market share by the end of this year at around 2%. We are not selling directly to utility companies because basically there are way too many of them around the world. We are going with partners to every country, to every market. This could be a switchgear manufacturer or a measurement device manufacturer or a system integrator. Therefore, you can find big names on this schedule. We are basically doubling our turnover every year since 2019, when the first venture company has invested in Greenwood Power. We are protecting our IP via patents. 3 of them are granted worldwide, and we have declared 5 additional ones. The most important benefit is the price-performance ratio. At the end of the day, the end customer will sacrifice some USPs if they get the cheapest product in the market. This is our approach. We are targeting the high-quantity market. We have a break-even in 2023, this year. We are constantly expanding our capacity in production. This is our biggest challenge at the moment, not sales, it's the production. And we are targeting to additional scale-up by end of this year.
Thank you. I do hope you have some questions would like to ask. Yes, there is one.
Thanks for the presentation. Since you shared your financials, can you go over how you're going to achieve margin expansion?
It is a shift happened in the past. We produced in the past at a production partner. We went everything in-house now. We're producing in Austria with 50 people and in Hungary with 20 people. If we have finished the complete shift of the production to the in-house production, we will have approximately 40% margin, including the contribution margin.
Thank you.
There are no more questions? Okay, so thank you very much for the presentation. Thank you. Norbert Jusic from Greenwood Power. Now, ladies and gentlemen, please welcome founder and CEO of Hey Charge. Chris Carde is with us. Hello, Chris. Good luck.
So hi, everyone. I'm Chris Carde. I'm the founder and CEO of Hey Charge. We are an electric vehicle charging company based in Munich, Germany, and we are unplugging EV charging from the internet. And you might ask why. It comes down to reliability and cost. We actually got our start looking at underground parking garages for like apartment buildings, and we realized that mobile app experience kind of falls apart if the mobile app doesn't have a network connection. But reliability and cost are problems that kind of echo across the EV charging ecosystem, from public charging to single-family homes to multifamily homes. And we realized we could fix it. And our core innovation is something we call Secure Charge. This is our patent-pending technology to relay data to our EV chargers, basically through the mobile app over Bluetooth. So let's kind of keep track of the problems we're solving. Both the EV charger doesn't require the infrastructure side of the connection, but also the mobile app works when it doesn't have a mobile network connection. And this is really transformative in terms of improving the user experience, the scalability, and the unit economics of EV charging. So we productize this in two ways. We have what we call our turnkey product, which is a ready-to-use set of software and hardware for multi-user environments. This is a great way to prove out the technology and has also told us that there's really a substantial demand for an elegant solution to these problems. But the real scale for the company is behind white label technology integrations, and we have both an HDK and an SDK that allow our partners to build any combination of chargers and apps enabled with our USPs of our secure charge technology. So we started off selling that turnkey product directly to apartment buildings, but we're now scaling through resellers globally. But the real fun starts when we start integrating these technology into third-party products and we develop that huge ecosystem. And that really opens up the whole market of other people's EV charging products for us. So taking a look at where we are, we have 2 scaling real estate asset manager customers for that direct HCharge operated business. So for example, like just to give a sense of size, one of these customers has 15,000 parking spaces in Germany. We have 1,600, actually 650 units committed through our resellers this year, and that gets us into the 7 figures of revenue. And we just signed our first commercial revenue deal with a US utility to embed our SDK into their EV charging app. We also have 3 partners working on ecosystem hardware, so we'll have a Works With ecosystem. Our team brings a ton of experience across automotive tech, energy, and I should have written mobility. And we are raising our Series A right now. That's $10 to $15 million. We have about 25 to 30% committed. And we are doing it because we sense a groundswell shift in demand and understanding for the problems that we are solving. Thank you very much.
Thank you. I'll take care of the remote. Now's the time for judges. Are there any questions you would like to ask? No? Chris, I believe everything was so clear that there are no further questions. Thank you for your presentation. Chris Cardet. Ladies and gentlemen, now it's time for Ionate. Please welcome Matthew Williams, founder and CEO of the company. Hello, Matthew. Good luck.
So innovation is key to our energy future. We know we need to decarbonize with renewables and EVs and mass electrification, but all of these things are powerless, literally powerless without an electricity grid that can support them. And here's the problem. Our power grid's running on technology from the 19th century. All this great innovation develops around it, but then connects back to this rigid, passive, and ancient network. It's like trying to stream Netflix on dial-up. Right? So how do we revamp such a massive machine that can never be unplugged? Well, that's what we do at Ionate. We solve this system problem with system-level innovation. First, we needed to invent new hardware to deliver meaningful improvement on the building blocks of the system, the transformer, which hasn't changed in 130 years. We call it the Hybrid Intelligent Transformer, or HIT. So in the past, you needed 3, 4, 5 different devices added on top of a transformer to get limited control. Our HIT replaces the transformer and does all of it in one device. So we give you data visibility, but we also give you real-time power flow control, independent phase voltage control, harmonic suppression, and power factor correction all in one. And we do so more efficiently and at a fraction of the cost than any other technology. So how do we do it? Well, we have a unique control methodology using magnetics. Where everyone else focused on building better electronics, we saw that this hybrid approach was better suited to the robust, precise, millisecond-level control required in the modern grid. This type of control at a substation level can help prevent issues that would otherwise cause blackouts, but because we're scalable, we can improve everything connected to the grid, from renewables through to data centers. So it's a really elegant solution. In fact, one of our utility partners said it's like going from letters to email. But you see, what our hardware really is it's about turning passive network nodes into active ones. So when you coordinate them, you get a system that optimizes itself. And that's the jackpot. So our software stack gives you the full grid operational data set, but it's unique in that it doesn't rely on third-party hardware to operate. So this coupling of our hardware and our software vastly extends the grid's capability to integrate DERs. It increases its power capacity for delivery, and it even reduces losses. It turns it into this smart, inherently efficient multi-highway system, and that's what our mission is. So we have a world-class team of experts that have done startups, worked with utilities, scaled technologies at the likes of Siemens and ABB. We work with established manufacturing partners. This allows us to scale up our technology really quickly and have the biggest impact. And we're going into pilot trials with world-leading utilities and private sector customers. So at iNet, we're really enabling an energy system ready for the 21st century. Thank you.
Thank you, Matthew. Yes, there is a question I can see.
Thank you for the presentation. How many years do you think it would take a customer to get their money back on the infrastructure investment for kind of a big grid-wide upgrade?
Really interesting question, because the direct competitor for us, I guess from a hardware perspective, isn't really a transformer in itself, right? And when you start looking at all of the add-on equipment that you need to do, it really depends on what the technical issues at that location they're trying to resolve for. So even at the top of our cost curve right now, we're cheaper than the alternative technologies. So payback period in that sense is zero, right? Because we're cheaper than the alternative. And it's not about just delivering an efficiency improvement. This is really driven by the need to make changes because of what's happening to everything connecting.
Great presentation. 2 questions. One, can you elaborate how your solution is better than top-down transformers? And 2, you mentioned scale-up earlier. It looks like your business model is very dependent on the ability and the willingness of the worst customers ever to deploy your solution quickly. How are you planning to mitigate that?
Yep. So with something like an OLTC, discrete set points, and it takes roughly, 1 second between each one. So if you want to scale from -10 to +10%, you're looking like 8 seconds. For us, we can go from that, any position within, it's not discrete set points, and in under a millisecond to respond and settle. So it's like an infinite tap changer. In terms of the customers, yes, utilities, that's the big picture problem that we're looking to solve. We see them moving a lot faster than they used to because they're starting to feel pain now. But where we're actually getting a lot of early commercial traction is more this private sector. So things like renewables, but especially things like data centers, big manufacturing and process, where things like power quality and trips and energy efficiency really cost them millions and millions.
Okay, Matthew, thank you very much. There are no more questions. There are only 2 presentations left. Ladies and gentlemen, please welcome co-founder and sales director of Tau Group, Filippo Veglia. The stage is yours. Good luck.
The history of electric power started when Galileo Ferraris and Nikola Tesla introduced the first AC motor, something like that. 135 years later, the electrification marks the need for a new technological evolution. It requires electric motors which works at a much higher voltage, are much more power dense, and sustainable. How? Well, the core of an electric motor is the winding, the brown coils that you can see there on top of the motor, made of magnet wire, which is an electrical conductor with a thin insulating layer. The electrical strength of this layer determines the performance of the whole machine. But the current magnet wire was designed more than 60 years ago and hasn't changed since. It cannot answer to the need of voltage resistance, power density, and sustainability that electrification asks. And here is where Tau comes into play. We invented a process called dry cycle to coat wire without solvents. Yes, traditional process make use of varnishes which contains 80% of highly polluting solvents, while we don't. And besides being greener, dry cycle works with technopolymers, which feature way superior dielectric properties. And superior dielectric is the best fit for e-mobility, because electric cars and electric vehicles in general require electric motors which are one order of magnitude more powerful than traditional one, with the same size. This itself needs magnet wire with outstanding performances. And we do have it. And we do it without solvent, cutting the CO2 emission dramatically. Plus, by allowing smaller electrical machine, we save on raw material, answering the concern for mining and geopolitical confrontation for electrification. So we have the best performances and the lowest environmental impact. This unique positioning is what motivated chemical leaders like Solvay, Daikin, or Altana to invest in us, because we are their gateway to the electrification market. This is what Francesco, Piero, Artyom, and I has been doing since 2013. And since then, we have raised 25 million. And now, with 60 people in our roster, we are focusing on scaling up the production capacity to meet the market demand, which will ramp up between 2024 and 2025. Thank you for your attention, and I hope you enjoyed our little story.
All right, thank you very much. So do we have any questions? Yes, there is one.
What efficiency gains can you expect out of deploying your cables in electrical motors?
The total efficiency gain has to be measured on vehicle size, because the efficiency on electric motor is already quite high. Yes, 1 or 2 points can be gained by using our wire, but the real efficiency gain is on the whole vehicle, because using our wire, you can increase the voltage, the power density, so the car will be smaller, lighter, working at higher voltage, so the whole system will be more efficient. We can talk about 50% in total efficiency gain, not only the wire on the motor itself.
Are there any more questions? No. Okay, Filippo, thank you very much for your presentation. Big applause for Filippo. Ladies and gentlemen, now the last contestant, VP Business Development and Marketing from Co-Energy. Please welcome Aviv Dekel. Good luck.
Hi, thanks for staying. I'm not sure if it's the best spot or the worst one. I'll let you be the judge of that. So my name is Aviv, and I am Vice President for Business Development and Marketing at Co-Energy. We are an Israeli startup in the field of waste to energy, designing and creating technological solutions for converting different types of waste to a variety of energetic outputs. We grew bootstrapping so far, and we're already commercially active with projects up and running. We have a medium-sized team of very experienced professionals, both on the technological aspect as well as in business management. Plastic waste we convert to hydrogen, electricity, or fuel, and organic waste we convert to biochar, which is a great soil fertilizer that also sequesters carbon. 1 ton of biochar sequesters about 3 tons of carbon. And through this capability, I will now show you how we can very easily reach the target of removing an annual quantity of 1 gigaton. Let's take our hosts from Poland as a use case. In 2020, households in Poland generated over 1 million tons of biodegradable waste that went to landfills. Let's convert it to biochar instead. You see right here that even with the most conservative estimates, this reaches the 1 gigaton target very easily. So the math works. Now let's execute it. Co-Energy's plants work in an inline continuous process 24/7. They are modular and scalable, ranging from 0.5 ton to 3, 6, 9 tons per hour and more. And with Co-Energy, it will take 30 plants of 6 tons per hour module to treat that volume of waste, which is not a lot compared to the enormous resources currently devoted to landfilling it. 30 plants by Co-Energy take less than 1% of the space of landfills, and they cost far less. Converting waste to energy is by far the most cost-effective method for waste management, rendering even illegal dumping not worthwhile. By converting waste to energy, you're not only removing greenhouse gases, you're also avoiding their emissions. And when we work in small-scale plants that are easily incorporated into existing infrastructure, like waste collecting stations or transfer stations, we reduce Scope 2 and Scope 3 emissions as well. And we're not only decarbonizing, we're eliminating a huge problem of waste and creating a high-quality tradable product. If we expand our perspective to the entire European Union, you see the potential. And even if just 10% of this potential is realized, we have met very easily the 1 gigaton target. Co-energy is already commercially active. We have up and running projects in Israel and some very exciting contracts happening in the Pacific and in Asia. And we are, in fact, decarbonizing in these volumes. We are expanding our reach into Europe and in North America. And we are now, in order to scale up to these countries, also commencing our first raising round. So it's a very good time to hop in. Let's decarbonize through waste to energy.
What's the major technical differentiator for your product versus others working in the space?
Okay, thank you for that. So first off, we work in a continuous process, not batch-based, which is very important in your energy conversion as well as in your maintenance and your lifespan of the system. Second is, our process is very meticulous. Waste is such a hard feedstock, it changes. No 2 tons of waste are alike. And if you want to create that high-quality biochar, also that meets the requirements of the voluntary carbon market, as well as its agricultural applications, then you need to control the process very, very accurately. So we have patents on the process, depriving oxygen from coming in, and we have patents on the software that controls the process itself. And our biggest advantage is that our system works. We have operational capability. We are well past beyond the proof of concept stage.
Okay, Aviv, I believe there are no more questions, so big applause to Aviv. Thank you very much. You were afraid that you're the last contestant, if it's good or bad. In my opinion, it's always good to perform as the last one, and believe me when I'm saying it, I was a contestant of Dancing with the Stars. It was many years ago, 15, and I remember each couple wanted to dance as the last one because we had a lot of votes, much more than the previous couple. So I believe that's the right order to perform. Ladies and gentlemen, now we've finished our contest, so I give now time for the jury to vote and decide which contestant will be, in your opinion, the best one, number 1 in the track. Tomorrow we will meet at 9 o'clock. I hope I will meet you all. I will switch with my colleague and do the tech talks, and he will take care of the Energy Tech Challengers stage. Thank you all for being here today with us. I hope you will have a lovely evening, and remember to join us tomorrow at 9 o'clock. Thank you very much.